Course 1 Math. Before we get to Lesson 24, just want a quick highlight of written practice question from Lesson 23. I've had a lot of questions on these types of problems in the past, so I want to make sure you feel comfortable. These come from, well, Investigation 2, but anytime we talked fractions, it's an interesting way to word how many 1/4ths are in 1. And what they're saying is add up individual slices that are worth a fourth. You know what those quarter-sized pie pieces look like from your manipulatives you made in Investigation 2. They're asking how many of those can you put together to fit into 1. So obviously, if you're just counting in fourths, you can get a fourth in 1. Okay, you can get a fourth, but you can get more than just 1/4. How many fourths? You can add up 1/4, 1/4, 1/4, and 1/4. That's 4 fourths. That 1, 2, 3, 4, add 4 over 4 really is 1, right? So 4 is the answer there. You can get 4 fourths. Another way to think of that is, what's a fourth of a dollar? 25-cent piece, a quarter. How many quarters fit into a dollar? Well, that's 4, right? 4 times fit into this dollar. How many fourths are in a half? Now it's really starting to get interesting, right? How many times do you add a fourth together? How many fourths will you add together to get to a half? These have like denominators. Do you add them together? You don't change denominators when you add. You just change the numerator. So the bottom stays the same, but the top you add together to be 2. And 2/4 reduces to a half, if you follow me. So what we were just doing there is measuring how many, you could take your little cutout pieces and lay them over a hole, a filled in circle, and see how many times you can put them together, and then how many times you can stick them onto a half and see how many that is. You can use the manipulatives that way. What we're really doing there was adding fractions with common denominators where the bottom matches so we can add them right away. And when you have common denominators, it's real nice because you don't have to do any more work than just simple addition and remembering. What I mean by that is, remember, you add numerators, which are our top numbers, to get 5 in 3/8 plus 2/8. But the bottom numbers, remember, don't change them. Don't change. Denominators stay the same, okay? So the sum of 2/8 and 3/8 is 5/8, and that is review. Denominator tells you into how many parts the whole is divided. Now subtraction of 2/8 from 5/8 looks like this. We take 2/8 from 5/8. Okay, again, just like addition and subtraction work kind of like pairs. They're called inverse operations. When you subtract, you do not change the bottom, the denominator. How many times we're measuring that the whole has been divided stays the same. It's just now how many pieces have we counted up? 5 minus 2 is 3. 3/8. How we doing? Let's wrap this up quick because I feel like it's review. Notice when we add the numerators, we add fractions that have the same denominator, and we subtract the numerators when we subtract only when there's the same denominator. So all these are nice and easy where we don't have to change anything and rename it. It's already all set up for us. It does get tricky if you start subtracting. Let's say I had 9/8. I have more from what I'm taking than what I had in the original. I don't even think they're going to make us do that. Last one, example 5. If I have a half and I'm subtracting a half, remember, one more time, tops change but not the bottoms. So I'm going to keep it measured in halves. But if I take a half from my half, I've got no halves left. So you can say 0 halves. You can read it. You can read this as halves, 3 halves, 2 halves, which is 1, 1 half, but 0 halves just is 0, right? Okay? So real quick, rattle off A through F because I think you should know them all, and it's just good to really cement that in your mind, how the bottom doesn't change. Denominator stays, numerator changes. Thank you.